So in order to find the radius using proportions, we use fade over 360 times pi r squared to represent the sector area, and fade over 360 times 2 pi r to represent the arc length. And we know that these values work because the sector angle divided by 360 represents a proportional part of the entire angle, and when multiplied by the area of the circle, we will be able to find the area of that particular sector in reference to the reference angle. And the same goes for arc length, as that proportion of the sector angle to the entire angle of the circle when multiplied by the circumference will give you the particular portion of the circumference that correlates with that angle, also known as the arc length. So using these values, we can set up a proportion to solve for the radius, or r. This is because in both cases, the only unknown value is r, because we have already identified theta as 190. And as a result, all we have to do is find the radius, is set up the ratio of the sector area over the arc length in terms of r equal to p, which we have identified as 80. So after we do this, we are actually able to reduce it by reducing 190 over 360, pi, and one of the r's in all of it, and we can eventually solve for 160 as the radius of the circle. And then here I've just checked my work to show that this proportion works when we find the sector area and the arc length of the circle, and we find that this proportion does equal 80.